Okay, this is a little AP Physics 1 review. This is going to be over Newton's 3 laws. Remember, his first law says that an object in motion will stay in motion unless acted on by an outside force. Mainly what you want to know is if something is not moving, then all its forces are in equilibrium. The up forces are equal to the down forces, and the left forces are equal to the right forces. So if you're ever asked to draw the vectors, the force vectors, on something that's sitting still, make sure the sum of your down forces is equal to the sum of your up forces. You may only have one up force and two down forces. Make sure you draw them so that the two down forces add up to the length of the up force. So if something's not moving, make sure you draw the forces are balanced. Use words like forces are balanced when you're asked to describe. Make sure you write everything thoroughly. Make sure you write enough of an explanation. This is not a time to be real cryptic. Also, in your explanations, use equations. Pick numbers. They don't give you numbers. They might say, what will happen if this is like that? You might think of a situation and say, well, if this one's much bigger than that one, pick a huge number there, a small number for the other one, and I will talk about that in just a minute. So let's take a look. What this typical problem like this. Remember, if they use the words negligible friction, you can just assume the force of friction is 0. So if we were to draw the forces around this one, remember, to find what forces are acting, make a circle around it. Anytime something is touching something else, there's a force acting on that. And then you have your remote forces like gravity. So for this one, you would have mg, and it's probably the best way to write it on the AP exam would be mg, or you could even do force of gravity, all right? But mg is a good way to put it. And then this way, holding it up. Now, if this is not moving, these would be the same direction. I would put force of tension for that, okay? We can just write T as well, as long as somewhere on that problem you write T equals the force of tension or something like that of the rope. So that's how you would find out what forces are acting on this. Now on this one, we know it's contacting there, and that's where you would get your force of normal force from the table, and your remote force would be mg, and these of course would be exactly equal because it's not moving up or down. Now this one, if there's no friction, all there is the force of tension. If there was friction, you would put an appropriate, if it's not moving, it would be the same length. But if it is an unbalanced force, it would be moving this way, so this would be longer than that. So only when it's an unbalanced force are the vectors different lengths. So if the friction is negligible, and these are fairly even in size, even if this is just double in size, it's going to move. I don't care if this is bigger than this. There's no friction. There's no force of static friction to hold it in place. It's like being in outer space where there's no friction and you just let a little air out. It'll make you move. So this will move. And this will be moving pretty much like free fall. So the acceleration will be very close to free fall, 9.7 or 10. You can use 10 in these. You can round friction to 10, mainly because if you're just doing an explanation, you can just write it in an equation just to show the relationships. So this would fall and it would move pretty close to 10 because there's no friction. However, according to Newton's first law, you have what's called inertia. Inertia is the resistance to movement. What if this was extremely big and heavy? Extremely big and heavy. Let's make this 1,000 kilograms, okay? And this 1 kilogram. Whenever the AP exam has something underlined, That's emphasis. So if they say something is greater, then think of it as a lot greater. It really means something if they underline a word in an AP question. So let's do our equations from Newton's second law and see how this would affect the acceleration. So with this one, we would have mg, so that would be 1 times 10, minus the force of tension equals mass times acceleration. See, down minus up equals mass times acceleration. This one would only be, since there's no friction, it would only be the force of tension equals mass times acceleration. Now we can substitute in to solve this and say 10 minus 1000A equals A. So 10 equals 1001A, and when we solve for A, we get 10 over 1001. Now that's a very tiny fraction, that's like 1/100th. So your acceleration is actually, the bigger this is, the amount greater this is than this, it will actually barely move. The acceleration will be getting closer to 0 in this case. So it doesn't seem intuitive. If there's no friction, you'd think, oh, barely take anything to make it go whoosh. However, when you plug into Newton's second law, then you see that, yes, the inertia steps in here, and the resistance to movement overcomes the fact that there's no friction.